Mode.
All right, everyone, just want to welcome you back to another KevCAM night class. Tonight we got Mr. Terry Hurley from California on with us to help us out.
Thanks, Kevin. Hello, everyone.
And Terry will be here to answer any questions, add to anything that I'm missing out on or anything like that. But if you guys are new to the class, what we do with the GoToWebinar is everybody is muted right now. We just do this to eliminate any background noise. But if you guys do have a question, there is a questions panel in there. And go ahead and type your question in there and we'll get it answered right away for you guys. If Terry doesn't know the answer to it, he'll just tell me to shut up and we'll get right on your question and get you your question answered right away. So first things first, for you guys that are new also, we also have submit your topic into myself and you can win yourself a t-shirt and hat. So if there's anything that you guys want to see or anything you want me to cover in the night class, these classes are solely designed just to help you guys out. So definitely send those over to me. And for those of you that don't have my email address, let me just copy and paste it in to the GoToMeeting for you guys. All right, so I just put my email into the GoToMeeting. Now, if you guys want to see a class that was done previously, all the classes are recorded, so they will be on YouTube. And if you go to SolidCAM University channel, or if you just type in KevCAM, it should pull up with all the classes. And here's all the videos in here of all the classes that I've gone over in the past, doing tool libraries to shop floor editor and all that stuff. And Terry, I don't know if you noticed that, but that picture kind of looks like me and you right there, doesn't it?
It does. I didn't know I was a machinist.
But so definitely come over to the YouTube channel, check that out, and let me put that link in here too. For those of you guys that don't have the channel, definitely subscribe to it so you guys will see all the updates. And I also put in here a bunch of helpful videos, like shorter videos, like how to set up a fixture on your machine, just a quick 1-minute video, how to use the shop floor editor, just a quick 3-minute video. So there's a bunch of helpful stuff in here for you guys also to take advantage. So definitely check that out. But I guess with that being said, we'll dive into it. Tonight we'll be covering 3D milling, and I know I talked last week and asked you guys if you guys want to go through each operation. So doing profile, face milling, HSS, every single operation inside SolidCAM. I got a lot of positive feedback, but unfortunately the videos were already scheduled into on the website. So we're going to do a 3D milling this week. And then next week we'll be doing HSS, but then we'll drop back down to doing just a single operation ones for you guys, and we'll kind of go through those operations with a fine-tooth comb. So starting with face milling, profiling, 3D contour, and kind of get going through all those. And toolbox cycles is another good one I want to cover for you guys, because it will definitely help you guys out a lot in the future, because there's a lot in there. So. But with that being said, let's get on to our 3D part. What I actually did here is I tried to get a model. I think you guys actually have a copy of this model in your getting started examples, but it's all been programmed with HSM. With this particular one, we are going to do it in 3D milling. Now 3D milling is a really good 3D toolpath, but it's not as expensive as your 3D Pro with HSM and HSS. This is SolidCAM's version of 3D milling. It has a lot of power in here, but it's at a much cheaper price, or more affordable price for you guys. But we'll kind of go through each operation in here, and I'm not going to program it live just because of the save and calculate time. There'll be a lot of dead time just waiting for it to calculate up. So what I'm going to do is I'm going to walk you guys through step by step of the 3D milling and showing you guys everything that's inside there. So, so getting started here, we're just doing a rough and semi-finish. So if I just start at the top, going on geometry, you don't have to pick anything for your target. Your target's already been pre-selected. Now, if you guys are planning on roughing out a whole part like what we're doing right here, you guys can just leave it at that and we don't have to go any farther. But maybe you guys want to work on just a specific area. So if you click on working area, you guys can come in here and we can select a certain working area. We can select on certain surfaces. We can just cut the rest material only. So what it's going to do is it's going to scan all the prior operations, looking at the stock versus the target, and then just machine anything that's been left over. So there's a lot of options in here. You guys can set up angle limits in here. You can do just doing trims just up to the upper level. So a lot of helpful stuff in here, but there's a lot of stuff inside the 3D milling. Even though it's a cheaper package, there is a pile of information here, and hopefully I'll go through all of that for you guys and be able to cram it in an hour here and get you guys more understanding on what's in here and how you guys can take advantage of that. So that's it for your geometry. Tool selection is standard as can be. Our tool is going to look the same as if we're doing 2D milling, face milling. All this is going to all be kind of look the same. And same thing for the levels. We got an upper level and a lower level. Now the lower level is just the lowest point on the 3D part you guys want to go. So what I did actually here is I went to the bottom of the part, but technically I really didn't need to go to the bottom of the part. I could have just went to the lowest part on the cavity, which is, you know, the point down here, and just click and maybe just go a delta a little bit past, because there's no point in taking a 3D toolpath and going over and down on a flat face. Just kind of wasting cycle time when we can just buzz around it with a standard profile operation or eye machining operation. Now, if we go to the technology is where all the guts are going to be. And kind of like I said with all the other KevCAM classes that we've done, technology is where everything happens. So right here is what I've chosen to rough using the contour feature. Now, you can do a bunch of different patterns in here, but you guys, if you want to do hatch, you can do contour, or you can do plunging. Plunging works very well too to really get bulk material out of there, because we can obviously basically drill out material much faster than we can mill it away. So, but for this particular one, we're just going to leave it on hatch. Now my overlap is kind of like the pocketing. How much overlap do I want on that cutter? And we're using a 375 cutter, and we're doing you know, 0.7 overlap and a 70 thou step down. And that's basically going down each particular time going around. So basically what we'll do is, can I get this pointed the right way? It's gonna rough it out and then move down 70 thou, and then rough out the whole thing, move down 70 thou, and it's not going to gouge on your actual SolidWorks model. Now what I've done in here is we have a clean flat section. Now on default this will be set to none, but what I want to do is I want to clean my flats during the roughing operation. So it's going to kind of clean out all the flats, and that's because I'm actually using a bull nose end mill. So actually I'm going to utilize the flat surface of that bottom of that end mill and clean up a lot of those flat surfaces. But, you know, with that being said, I'm still leaving 20 thou on my wall and 20 thou on my floor. Now, if we go into the Z entry, I have a couple different strategies, but since I've picked the part and I told it to do external, it's going to automatically start from the outside and work its way in. So I really don't need to bother with anything in here. If I go to my mode, I'm going to do it as a profile, approaching from the outside. Now in my data, I can actually choose the angles I want to approach this at. So let me just exit out of here and turn on our toolpath. You'll see that our toolpath is, you know, going all around here. But if I wanted to, I can change angles on this so it would basically approach it at a 45-degree angle, moving back and forth, doing it that way if you were doing like a hatch pattern. And you can kind of see right here in the picture, given a good representation of what angle is actually used for. Cutting direction, we can say yes, no. If I want to do a zigzag or one way, you can also set on your corners, anytime it gets into a tight corner, it automatically switches it over to a fillet, and you can put that radius in there so you don't get those sharp, jerky machine moves in there when you're doing some high feed roughing features in there. But we'll just leave that to none right now. Now, the same thing kind of goes down here for the fillets. You can put the internal or external fillet there. Now, if we get over to the semi-finish, basically we roughed it out till 20 thou above, then we're coming back and do a semi-finish using that 1 thou. Now, if you guys have 3D eye machining, basically none of this even takes effect because, 3D eye machining, you just pick the tool and you go to town and it's going to automatically leave that scallop height, so there's no need to do a semi-finish. But we're kind of just doing 3D milling, so we're roughing it out, leaving 20 thou on the wall, and then we're doing a constant Z semi-finish, leaving 10 thou on the wall. So we can come back with a ball and mill and get real nice looking toolpath on there from roughing it out. Now when you guys do semi-finish, you guys have a lot of options in here. Doing linear, and as I kind of click through, you can kind of see the pictures kind of change. We do offset cutting, we can do spiral, and I'm going to go through all these operations. I kind of set them up all over here so you guys can see which one does what. Circular pocket. And circular pocket, these toolpaths don't have to be on a 3D surface. If you guys want to do a circular pocket, doing, starting on the outside and working our way in, doing a spiral, this is what we're going to be looking for, the circular pocket. Get a really nice, pretty toolpath in there. If you guys are going for a visual, it just kind of looks like a big old spiral in there. Also have constant Z for more of our vertical walls. Linear works more on the flat stuff, and constant Z kind of works better on the more vertical walls. Pencil milling, just for working on specific little areas. And then basically it's a 3D constant step over. For those of you guys who use HSM, we have the 3D constant step over there. And basically it's just doing a constant step over of whatever we tell it, and maintaining that step over throughout the entire part. So it doesn't matter if it's a straight up and down wall or a more flat wall, it's just going to do that constant step over. But we'll leave it on constant Z right now. Now, as I switch over to the semi-finish, I also have a whole nother, entry points that I can set up, so we can, set up long pass, between pass, or you can leave it to none, and then the data. Now, in the data right here, what I want to do is I want to do a constant step down. If you guys wanted to keep a constant scallop height, then you can switch it over to the variable step down, and the scallop is going to stay at that 5 thou all the way throughout the part. And the scallop is basically your step over. Maybe if I turn this on, I don't get a picture for this one. But the scallop is from the bottom to the top of the cusp height, I guess you could say, is the scallop height. So basically it maintains that constant scallop height. So the difference between constant step down is we're telling it just to step down every 20 thou. On a more vertical wall, we're going to have a larger scallop versus a smaller scallop versus a more flat wall. We're going to have a larger scallop, where over here it's going to maintain the scallop throughout the entire cut. Now, we also have connections, so if you guys want to do tangential connection or doing stairs, definitely totally up to you guys. You can put the approach radius in there. Now, if you guys want to start from the top and work your way down, or vice versa, climb cut, conventional cut, zigzag one way, like I said, a lot of options in here for you guys. If you guys have questions in here that I didn't cover, or that you have more questions about as you guys get programming on and you forget about it, definitely hit the question mark and we can click on it, and it will pull up the help menu for you guys, and it will give you a reference of what's going on there. So you guys can also do a constant Z flat floor finish here. So you can set it up so on the constant Z flat floor machining, maybe we just want a different scallop with a max step over of being 100 thou or something smaller, and you guys can actually choose the contour style, which is your kind of like what we're doing right here, or doing a hatch, which is just going straight lines back and forth, and that will, you can get a nice finish doing that. Now this screen right here is going to look the same as if you guys are doing semi-finish or finish. So I'll kind of cover that too, and you guys will be able to see, there's really not much difference between the semi-finish and the finish. Just with the finish, you get I think just one more option of tool path. I think it's the Constant Z spiral finish, if I remember right. Yeah, the Constant Z spiral finish is added in the finish, but the only other thing that's actually difference between semi-finish and finish is you guys don't have a wall offset right here, and we can turn comp on and 3D comp on with the finish. So that kind of covers that page right here. Like I said, I know there's a lot in here, and I'll kind of go through the Constant Z pencil milling, all that stuff with you guys, but to kind of give you a clear picture of what's going on here. But like I said, there's a lot in here, and there's a lot you guys can do in here. Now, if you guys want, you guys can turn on tricoidal cutting. You just set your radius, step over, and the max angle engagement you want to go, and it'll kind of come in there, kind of like the eye machining, but just does tricoidal cutting. So it's basically like little circles just kind of going in there, getting material out. So now if we go to the link like always, from profile to face mill to anything, our link is going to be basically our lead in, lead out. So you guys can set it to percentage of tool, or you guys can set it to distance. I'm just going to leave everything kind of as default here. Now, going farther down, stay on surface with the gap of basically how far you want to, your tool to come off the material as it's going to a new connection point. And, you can do along the path or between paths. So if it's, making slices in there, it's kind of like your HSS, your links is basically how I can kind of explain it for those of you guys that use HSS. So you guys can set those numbers much smaller. You guys can set them much greater, and you'll actually have, higher or lower repositions along there. Now, if you guys want, between repositions, you can do a rapid through clearance, you can do feed through the safety, or rapid through the safety. We can set that up however you guys want. For the most cautious would be feed through safety. But if you guys have a part, proved it out, everything's good to go, let's save some time on the production or something like that, definitely use the rapid through safety from surface. So you'll definitely eliminate a lot of the feed moves in there, replacing them with G00 moves in there, or high feed moves. So now the tolerance. Now the tolerance you can set as tool curvature or surface curvature or side step. I honestly, guys, I'll never touch this right here. I always leave it on the default. I always stay on surface curvature, and you guys can set the default value. Basically, it's the tolerance of the model. Now, we already kind of set up the tolerance of the model when we set up our target, but this is another spot where you can set up so you get much smoother. The more larger I create this, the more straight line moves we will get, and the smaller value we put in there, the more smoother lines we'll get in here. So, usually default, this page you can basically skip over and just get to link and skip the rest of it, but we'll definitely go through it. Now, motion control. If you guys want to do interpolation for distance, you guys can set that up. Rapid feed rates, you guys can set that up also. Like I said, a lot of this stuff, honestly, since 2007, since I've been using software, never even touched this stuff in here. But if there is something in here that you guys need, approximate arc by lines, we can change that down. So instead of doing line segments, doing arcs, here's your tolerance for that. Now, if we go to miscellaneous parameters, miscellaneous parameters is basically going to be the same through any operation. Again, you have your optional M00 stop. You can add a stop message in there. You can do, your G187. This is a Herco machine, so basically the accuracy of the cut can be set right here. On this, the 187P and the NG 187E is basically just for the Herco machines. So that's, I mean, for those of you guys that know Herco, that's it. But, you know, if you guys are running Haas, these actually won't even be in there. So I'm trying to switch it up between using a Herco machine to Haas to regular just Fanuc control. So I'm trying to change out posts as we do different parts in here for you guys. So,
Hey, Kevin. Rob, I had a question. May I know how to set up in Target?
Yeah, when you guys, let me just exit out of here. Now, when you guys start a new SolidCAM operation, here's your target right here. So basically all you have to just do is just click on it and just click on your SolidWorks model, and that's it. No need to do anything there. There is a tolerance in there of that target, so your facet tolerance. And for those of you guys that don't know facet tolerance, this part is actually broken up into triangles. So the tighter the facet, or the smaller the triangles are, the more accurate it is going to be. So now, to answer that question in two ways, if you guys had multiple different targets, in here you can also pick different targets too. So there's another spot you can pick a different target just specifically for 3D machining. Now if you guys are doing you know, a profile or face mill or any 2.5D stuff, this isn't going to be there. But we do give the option, if you guys have multiple different targets, you guys can actually pick different targets in there. So let's go ahead and simulate this and see what it looks like. Like I said before, you guys can take and do the host CAD, and I can uncheck this and just kind of show the toolpath here. And basically what we're doing is getting a wireframe of what's going on. If I want to show the tool, you guys can see the tool here. Just getting basically everything roughed out for you. Then if we want, we can also do the solid verify and get a little bit better, clearer picture of what's going on here. So we're roughing it out, and now it's coming back through and doing the semi-finish operation here. And the semi-finish and finish, it can all be done all in one operation if you guys want to. And obviously with the 3D part, it takes a little bit more time to calculate. And I do have my accuracy set very tight for my solid verify, so to give you guys a really good picture. So that's why it takes a little bit longer. But you'll see we basically just roughed out that whole cavity right there from top to bottom. You know, and what I was talking about scallop heights is basically right here, the height of this point down to the valley is your scallop height. So when I was kind of mentioning that earlier, for those of you guys that were unsure of what I was talking about, that is your scallop height right there. But so like I said, we basically roughed out this whole part and did a semi-finish, and now we can come back at it with a finishing operation, or we can come back with a semi-finish using a smaller tool to get in some of those areas. So what I'm going to do is just kind of show you guys what it would look like if we just did roughing only. So everything's going to still be the same. Our geometry's, you know, still going to be our target, still going to use our same tool. Levels are still going to be set up the same. So now I'm just going to do a contour. Oh, looks like I turned on constant Z. So this one's the same. Let's just do a semi-finish only. So right here is just doing semi-finish. So maybe we came back with tool number 5. We roughed it out. Maybe you guys are using a pretty aggressive corncob cutter in there, you know, or whatever you guys want, and you guys want to come back and do a semi-finish with a different tool. You can just make a copy of what we did before, basically by clicking the Save and Copy button down here, and then we just do the constant Z. And so if I just do a show right here, this is basically what the semi-finish is showing you guys. Just kind of coming up in there, cleaning up some of the areas that got left over, but we're still leaving 10 thou on the wall. Now for those guys that are a little bit new with SolidCAM, if you guys want to see your toolpath and this dialog box is in your way, if you guys are just running one monitor, you want to keep everything on one monitor, what you guys can do is just double click right here, and it will actually kind of shrink it up for you guys, and you guys can, you know, take a peek at what's going on here. Just double click it back down and it will populate for you. So just kind of want to show you guys a quick little trick. So that is doing just semi-finish only. I just kind of want to show you guys what it looks like in there. I'm not going to solid verify it just because we already did the semi-finish over in our rough and semi-finish right here using that same tool. So now what we want to do is we're going to do the semi-finish in a linear pattern. So basically just going from the top and just doing a zigzag going back and forth, going over all these surfaces. So like I said before, everything is still going to be the same as what we've used before. We are going to switch over to a smaller tool. If you guys want, you guys can, what I did here is I switched it from my working area to center instead of doing external. We can do the cut only rest material also, but basically I want to do a nice semi-finish pass over the entire thing. So level is still going to stay the same as before. Technology now. What I'm doing here is I'm switching it over to linear instead of doing constant Z, leaving a 10th wall offset, leaving my Z entry there. But now what I'm going to do is I'm doing a zigzag pattern with a scallop height of 5/10. So the smallest my scallop is going to be is 5/10. Now I set up a max also, just because our tool path would be calculating for a while using 5/10 scallop height. But if you guys want, you guys can just do a one-way. You can do a one-way upward, one-way downward. So a lot of different options in here for you guys. Maybe you guys want to kick it off by a 10-degree value. So instead of our tool going back and forth this way, maybe we want to approach it at an angle, like I was kind of showing you guys before. If you guys want a cross finish, you guys can do a normal cross finish, or we can do a smart cross finish with a minimum step over. I'm basically just kind of doing another pattern of finishing for you guys. Haven't really used this one much right here, but the option is there to set up a more normal cross finish. Let's see what it says right here. Oh, it just brings up pencil line. Okay, so we'll just leave it to none for right now. Scallop height, kind of went over that, but if you guys wanted to, you guys could set it just to a constant step over too, like what we did with the semi-finish. So we're kind of doing a semi-finish over here with a constant step over, and now we're switching over to the scallop. So with that being said, that's it. The link is still going to stay the same. A good rule of thumb, and this is what I was taught way back when I was using SolidCAM, is kind of keep your stay along surface gaps, keep that close to your tool diameter or twice the tool diameter. So we're using a 1/4 inch, so I set that actually up to 0.5. Now if I was using 1/8 inch, maybe I would use 0.125 or just do 0.25. And I'll kind of cover that in the pencil milling too, but definitely kind of use that as a rule of thumb here. Kind of keep it close to the size of the tool, or nothing over twice the diameter of that cutter. All right, so let's do a simulate here, and we can actually show you. Let's see, no. Uh-oh, now it wants to calculate. Give me 1 second here, guys. Okay, there it goes. Now let's just do a simulate here, do a solid verify. And now basically our tool, like I said, is just going to do a zigzag back and forth. And so that, like I said, I'm not going to machine this part in full here, but I'm just trying to show you guys different examples of what the 3D milling can do for you guys. So like I said, we're just doing basically a straight zigzag back and forth, just kind of doing another semi-finish, knocking down some of those cusps. So if I kind of get over to this side here, you'll see that my cusp height is much smaller now, getting a much better to come back with a finish cutter in there. So we're kind of eliminate a lot of the nubs and the bumps on there from the roughing operation. You kind of see right here a little side shot of this this kind of hub right here. So definitely the sky's the limit on what you guys can do inside 3D milling. But like I said, it's a much cheaper package, I guess, for you. I guess you guys could say. So that is the semi-finish using the linear. So
yeah, Kevin, let me touch on that real quick. Basically, what you're looking at, the 3D standard product, which does not include eye machining, is priced pretty close to what the 2.5D with eye machining is. They're both around $5K, but you can add just a 3D tool pass. For example, I had a customer recently that bought 2.5D Pro, and he added the 3D milling module to his 2.5D Pro. So that allowed him to do, eye machining, 2.5D, and also 3D with our standard milling package.
Yeah, absolutely. And that's kind of what we set it up for you guys. Is it's not the professional package, and I don't want to knock the package at all, but it is a less expensive package for the kind of the hobbyists. Maybe you're not running high production. It doesn't have the most efficient tool paths to get you fast cycle times and stuff like that, but it will get the job done for you guys. And like Terry is saying, you guys can, if you guys are looking, you have 2.5D Pro right now, and you guys just like some of the tool paths, even like I said, even if you're not running a full 3D part like we're seeing right here, we can definitely take advantage of these tool paths just on a 2.5D pocket. Getting that 3D circular pocket, getting a really nice visual, tool lines on there. So if something's, a customer is going to see, and they want to, the nice pretty lines in there, you guys can add that in there where you guys don't have that option inside the regular pocket operation, right here. So like I said, don't look at it as just doing 3D parts only. Definitely take advantage of, some of the tool path in here, to really hog out some material too. So, all right. Thanks, Terry, for that too. All right, so we're going to do the finishing, and what I basically did here is my geometry is still set up using a 1/4-inch ball end mill now. No, we're using a bull nose. I'm using a bull nose on this one, sorry. Level's still staying the same here. Now what I'm doing is I'm just going to leave my roughing as none, leave my semi-finish as none, but now I'm just doing a constant Z. Now, in here, I have my Z strategy. Like I said, I'm just going to set this up as none, but I do have the option to do angle along pass, angle between pass, and stuff like that. Also, in my data now, what I did is I set it up as I want to have a max, the scallop of 5/10, a max step down of 20 thou, and a minimum step down of 0. So, and what I'm going to do is I'm going to do a tangential connections, and the connections, if I didn't cover that well enough before, the connections is your paths that are, let me just shut up and I'll just show you. So the connections are your movements that come outside of the part. So we don't really have a lot of connections right here on this particular toolpath, but with our linear path that was just doing zigzags back and forth, the connections is between those lines. So let me just turn that one off, and these connections right here. So you'll see we have just straight line movements right now, but you can set those connections up as doing, where am I at here, connections. We can do tangential with a radius in there. So you guys don't get those sharp lines in there. Let me open that one back up here. So get back in here. Now I want to do climb cutting, just doing one way because we're starting to get into the finishing side of things, so we don't want to do zigzag back and forth. And then what I want to do is I'm setting up my to finish up my flat floors, leaving a scallop of 2 thou, max step over 20, basically kind of the same as what I did up here, using a contour style of finishing path on the floors. So if I hit OK here, Did I forget anything in here? And what I want to do is I want to complete it down to the Z level. Now, if you want, you can add vertical walls with fillets. You can do your arc approximation here. So a lot of options in here for you guys. Now you have arc approximation just for doing your finishing of your floor. You also have arc approximation in for your constant Z finish up here. So like I said, there's a ton of stuff inside here. So now if we want, we can turn on comp and do all that good stuff too. So let's take a peek at what it looks like just doing the constant Z here. I'll play this through here. And this is going to take a little bit of time just because I do have my tolerance set up for my solid verify. Now, for those guys that might be a little new, you guys can click on here and click on accuracy, and it's going to show the facet tolerance. And like I said, I have it set up pretty tight right here. Normally, default when you guys do an install, it's going to be set to 4 thou. And it's basically just visual and visual only. How accurate do you want the solid verify to look? So for those of you guys that aren't sure where to set that up, basically just come up to your settings right here and do accuracy, and that can tighten your accuracy up. Now under general, you guys can set up, if I want to do by fixed frames, so we're skipping every 15 frames a second right here, or what I can do is set it up by a fixed number of steps. Now, fixed number of steps is basically lines of G-code. So if I want to show every single line of G-code, I can click on by fixed steps, set that to 1, and it's going to show me every single G-code line. Now, if I want to skip, every 15 lines, you can set that up too. And same thing with your crash detection. You can turn stuff on and off here. Rest material. Honestly, guys, I've really never even touched this. So I would just, keep it with the default values. Now, down here is your rendering. Is basically, do you want to use your video card? Do you want to use your internal card? So if you guys aren't running a NVIDIA Quadro card, or if you guys aren't running, a higher end video card, you guys can switch this over to software OpenGL, which is basically going to do your internal card. Or if you guys are actually set up using the Intel for your graphics card, the built-in Intel card, use the DirectX, and that's what that one's basically set up for. You'll get much faster results than using the software OpenGL. So if you guys don't have the graphics card there. All right, we'll let this play through. And like I said, we are using a bull nose end milling here, so it's not going to get a lot of the areas. But it's basically just starting at the top and just working its way down, getting all that material finished in there. And if I kind of zoom in, let's get an area that's been done here. We have a pretty nice finish going through here. Kind of get zoomed in. So we got a pretty nice finish. Obviously we want to come back and do a ball end mill on something like this because we can see our lines. So we're getting a little bit of lines there, but we're really zoomed in on this part right here. So basically, if you took your part underneath a magnifying glass, this is kind of what it'd be looking like. We zoom out a little bit here. You'll see that we got a nice finish. This is a fairly large part too, so nice finish. And this could basically be a mirror finish in here. You just kind of come back with a piece of Scotch-Brite or whatever, and it would really blend real nice. So that is the Constant Z finishing toolpath there. So now I want to go over the circular pocket. Now, like I said, circular pocket, another great finishing operation, but you get that really cool looking pattern going on. So what I'm doing here is kind of doing a nice circle, working our way from the top, just kind of working our way around, just doing a circle. But what I've done over here is in my geometry, I've told it just to stay to a specific area. So let me just do a show. And I've told it just to stay inside of this boundary area because I don't want to do a circular tool path for my entire part. But I just want this area to look real nice, like I said, more for cosmetic maybe. So I set up that boundary area, and I told the tool to stay on center with that. Now, if I wanted to, I can set it to internal so that tool doesn't go outside of that boundary at any one point in time. But, you know, what I want to do is I want to kind of keep the tool centered so it kind of goes all the way up and over a little bit, just kind of focusing on that bull nose end mill there. And this doesn't have to be done with a bull nose either. It can definitely be done with a ball nose or a flat end mill. So like I said, this particular operation right here, if you guys want to use a flat end mill and maybe you want to use it on a facing operation, getting that material out of there, this is a great opportunity just to face off the top of your part using that strategy, using the spiral feature. Kind of switched up my levels a little bit. So on the top of my part right here, my lower level is going to be right here. Now in the technology where we get into that, Z entry is going to be the same. Now, as I kind of go through these, your circular pocket and stuff like this, sometimes you'll actually have more stuff pop up under your Z entry. So, you know, if you're doing circular pocket versus constant Z versus linear, different options will pop up in here for you guys. Now, in my data, I want to do a climb cut. I want to start from the inside, working my way from the outside, and my connections are going to be all smooth. Connections is the between the passes. So we want to do there, and I'm doing a 5 thou step over. So pretty fine step over in there. And like I said, we'll do our link, keeping the same right there, and staying on that curvature. So, you know, a lot of times you guys probably won't just get past this point. You guys can set up, you know, your gaps a little bit smaller, lead in, lead out, but a lot of times that the default is good. So, you know, basically just have to set up that geometry if you want to do it to a specific area. Just pick your tool, pick your levels, and then come in your technology and just pick your options in here and go to town. Let me get out. Must have changed something in there. Okay, so let's do a simulate here. You guys will be able to see as soon as it pulls up here. Like I said, this part is quite large. I should have picked a smaller part so that calculation times will be a little bit faster. But now I'm going to switch it over to by fixed steps, and let's just try every single step. So every single line of G-code will be shown here. And hopefully that's coming through, showing up smooth for you guys, just doing a nice spiral working its way out. But like I said, you know, you guys can use this for face milling. You guys can use this just for flat areas. You know, like I said, it's leaving a real nice spiral, you know, contour look in there for you guys. So getting that nice finish in there. Does anybody have any questions so far? I've been kind of rambling on for the last 45 minutes and didn't give you guys a chance to ask anything. Let's see. Dwayne, you were late
to class. You're doing such a great job.
Yeah, either that or we put him to sleep, Terry.
That, it could be one or the other, yeah. Yeah, I think you're doing great.
Dwayne, did you get your, seeing that you came in here, did you get your package yet from your SolidCAM swag from the contest? Not yet. Okay. There might be a little bit of delay since we had IMTS last week, so it's coming, Dwayne. Definitely won't forget about you. Just with the IMTS and the crazy madness that goes on there, got us a little bit behind in the shipping department. Dwayne, it's going to be attention to you, not to your boss. Dwayne said he thought his boss might have taken it. Okay, so that is the circular pocket. And like I said, guys, don't use it just for 3D. Definitely check it out for, you know, that 2.5D stuff. So now what I'm going to do is show you guys the spiral. Spiral is kind of just doing another spiral cut. You can also use this for flat areas too. And actually what I did is just doing a spiral just on this specific circle right here, and I didn't tell it to go out in this area. So if I go to my geometry here, my working area, do a show, you'll see I just contained it just to this circle. We can't even talk anymore. The circular area right here. So like I said before, it's basically just a boundary, kind of like how HSM, you set up a boundary. If we wanted to do it like HSS, where you just click on the surfaces, we can do that also just by clicking on selected surfaces down here. Now, with my experience with the 3D milling is I always found it works better using the working area, and I think it's just because it takes less time to throw a bounding area on there than it is to click on individual surfaces. Now, if you guys are just working on just one surface, definitely going to be much easier doing it that way. But it's totally up to the part and the part that you guys are working on. So, all right, let's hit OK here. We're going to be using a 1/4 inch ball nose end mill now just to do that pocket. And the entry's going to be at default. And what I'm doing here is I'm doing a spiral. Now if I want, I can do a linear or I can do square using arcs instead of lines. And we're going counterclockwise. I can put different start angles in here. I can put my different end angles in here. I can do deltas. I can do start spots right here with the radius. I can pick the spot where I want to start. We can also do zigzag. You're not going to get as nice of a finish using the zigzag just because we're changing cut directions throughout there. But at least with the one-wayer, it's just basically starting at the top, just working our way down to the bottom. So.
Hey, Kevin, Tim Benson had a question. Where is it that you set the parameters to keep the tool in that one area?
Right here. If I click on geometry, under working area, I told it to work on this specific area, so this area right here, and I want it to stay centered on the tool centered within that area. So with that, let me get out of here, and where's my tool at here? Come on, tool, pop up. I gotta turn it on. Come on.
We also have another question from Saul. Kevin.
Yeah, give me 1 second here. I can't get my tool to pop up right now. Come on. Oh, it's not popping up for me. So, oh, there it is. Well, where'd it go? So basically what I told it is I want the bottom of the ball to stay centered with that line that I drew in there. Now if I just wanted to contain it just to staying 100% inside there, then I can just say center. But or I'm sorry, internal. But center and tangential are pretty close to the same when you're using a ball. The bull nose is where that's going to change, or the square nose end mill is where that's going to change. The point there. So does that kind of answer your question? Okay, yep, got it. Okay, what do we got from Saul?
There was a couple of them actually. You see it?
Let's see. How would I do a constant step over cut without having tool trying to cut the walls in a round or in regular cavity? Because I've tried this. It surfaces the floor but still tries to go up the wall in some areas. So basically, Saul, what you would want to do is just do, for that particular one, what I would do is instead of doing a working area, I would work on selected surfaces. So what I would do is, if I wanted just to work on this surface right here, but I didn't want it to touch the wall over here, is I would turn on my selected surfaces, and let's just say I wanted to do this one right here, but I didn't want it to touch the radii right here, so I'm going to do my check surfaces, and check surfaces basically telling it not to touch those areas. And that's how you would tell it to stay only on this surface and don't touch anything over here. So does that kind of answer your question, Saul? Did that, but still trying. Well, Saul, what we can do is we can do this one offline, so I can actually take a peek at your part. And it's hard to tell what it's doing, what it's not doing without seeing your part. So definitely hit me up via email, and we will take this offline, and I'll look at your part. And this goes for any of you guys that have questions on parts. As you guys have questions on, maybe it's on your particular part only, definitely give us a call on the support line, or shoot, excuse me, shoot me an email, and we'll get those questions answered for you. So that's how you would do it, Saul, but obviously we're running into a little bit of the issue there. So what we'll do is, like I said, just shoot me an email. You should have my email address in the GoToMeeting chat area. So let's go ahead and trying to make stuff so it's not having to calculate for you guys, so you guys don't have to wait and keep breaking it by clicking on stuff. Okay, so we'll do a simulation here, and we'll do a solid verify. Like I said, I know this one is, you know, we're basically, you know, this part has been finished, but you can kind of get a good view of what the toolpath is doing here. So we'll hit the play, starting in the center, and just doing it basically just a corkscrew working its way out, going right up on the surfaces. So kind of similar to the circular pocket, but it's just doing a perfect spiral, working its way over. Okay, I'll set up a meeting with you. Perfect. So yeah, just let me know when it works best for you. And you'll notice, you know, the simulation is going a little bit slower, and that's because I'm showing you guys every single G code that's popping up. So, you know, you can see all my X, Y, Z moves that are going on right here, feed rate, my spindle RPM, what line number I'm actually on right here, and the cycle time. So that circular pocket, we're only, you know, 42 seconds in right now. So 47 seconds total cycle time. So, oh man, see, time is running out on us, Terry. Okay, so let's get on to finish.
Time flies when you're having fun, Kevin.
It does. Here, I thought I had a good half hour left. But, okay, so now what I'm doing is just cleaning up the tops. So I just want to just do, basically just clean up the top islands just to a specific area. So on this one, what I did is I did do the select faces. So if I just show you guys, I just wanted to clean up these faces right here, and this is kind of what I was telling you about Sol, but you know, I just want to do those specific faces and those faces only, don't want it to touch anything else, just want to do those. Going to use that same 1/4 inch. Go ahead.
Dwayne had a question. Can I slow, and then a follow-up with it.
Okay, can I slow the tool on a specific path? No, what you'd have to do is, Dwayne, I guess you would be asking if, you know, if you're doing a finishing on the entire part and you just want it to go slower over a certain section and then speed up as it's gone over that section. Unfortunately, we don't have that in there. And I don't even know if that's possible. I would have to talk to development and get back with you, Dwayne, on that one. But as it's right now, it's a constant feed rate going all the way through, so that feed rate isn't going to change. The only time that feed rate does change constantly is if you guys are roughing it out using 3D iMachining. So 3D milling, so there is, yep, yeah. Yeah, so, I mean, you know, and I haven't, you know, heard, but I know there is talk of doing 3D iMachining finishing path, so it's going to speed up and slow down to account for the areas, but it's still kind of out in the future, so don't hold me to that, Dwayne, because I know you will. So, okay, so now in the technology, just doing a constant step over, you know, another one of our passes here, Z entry is still going to be the same. My data, now what I'm going to do is, I told it to do a pocket, and what I did is, I just chained the pockets into these areas, so it definitely stays 100% contained in there, doing a one-way, doing climb cut, starting from the outside and working our way in. Basically going to be doing a spiral in there. Even though we're not doing the spiral here, this would be another spot you could do the spiral cut. So we're just doing a constant Z step over. So just constantly just stepping over for you guys. And show you guys the toolpath here. Basically kind of just doing a pocket operation. Start on the outside, just work our way in, stepping over, moving in, moving in, moving in. Let's do a simulate here. And let's do a solid verify. All right, so now we want to clean up those flat areas. Go ahead and hit the play button here. Oh, actually, I told it to start from the center and work its way out. So we're probably better off starting on the outside and working our way in so we don't have that straight line going right through there. Oh, looks like that one did. I must have my chains going one direction, going a different way. Cleaning up the flats. That one was already down to size, so that's why we're not seeing any color going on there. And cleaning up those flats there. So, like I said, definitely use those, you know, those 3D toolpaths just to cover up some of the flat areas. So now what I'm going to do here is I'm going to do a finishing with the constant Z. And I'm going to save and calculate this because this one takes just a little bit of time here. Hopefully it doesn't take too long. And basically what I'm coming back with is a 1/8 inch ball and mill. And it's basically kind of doing laying a blanket over the entire part. So what it's doing is it's covering the whole entire part up in my geometry right here. So it's covering, like I said, kind of laying a blanket over the entire part, just machining everything that was left over using the constant Z. Once it gets done calculating here, like I said, this part is very large, so it doesn't, does take a little bit of computer power to calculate this, but now is a great time for anybody to have any questions here. Nothing? Okay.
It's just that all your classes have made them so smart with SolidCAM,
Yeah.
and they just don't have the questions.
Yeah. So let's see, what else can I show you guys while that's calculating here. Now, if there are parts in here, you know, the KevCAM classes, I'm just taking some standard parts that are in there. But if there is parts like the C-axis, C-axis wrap here that you guys want, definitely let me know. I try to kind of get rid of the parts as soon as I do them, but I did have a couple requests to, you know, for people to actually get the parts when we're done with it. So if you guys do have that, I will start keeping the parts on hand for you guys, so you guys can kind of review what I did also as you're going through the video. So if you guys do want those parts, definitely let me know. Maybe what I'll start doing with each class is I'll upload them to Box, and that way you guys can just download them right inside of the YouTube video and have that right at your convenience. But see if this thing's done calculating yet. Yeah, this one's a little bit of a bugger. I set the tolerance really tight so it gets a really mirror finish in here, to basically be a fully finished part, and that's why it's taking so long. Another one I was going to go over is the pencil milling. Pencil milling works great for, let's say, this surface right here and all these radiuses. What you can do is just tell it to do pencil milling, and you can actually tell it just a number of cuts. So maybe if you guys just want to do one cut and you just want to go up at a 3D angle surface doing that that radius at the bottom, you guys can just limit to one cut and just do the one cut following that ball all the way up a 3D surface. It's kind of like the HSS where you guys can do the determine the number of cuts, is another good way of putting it. So. Okay.
Kevin, did you see Dwayne's comment?
Let's see. We got
about a PDF. He's asking if there's a PDF of what.
And we got a lot of questions. Okay, awesome. Clearance.
I think you got most of them.
Okay, I saw the transformations webinar. I still need to learn how to machine on top of my part on a trunnion rotate. So that would be a great time to get some of your training hours. Mark, for those you guys probably don't even know it, but you guys actually have training hours built up. These are hours that were included with your package that you guys bought, but you guys have training hours. And if you guys have questions on that, let me know, and I can tell you guys how many hours you guys actually have. But you guys have training hours.
Excuse me, Kevin. The same with me. If any accounts, even if they're not my accounts, if you just shoot me an email, give me a call. My email is terry.hurley@solidcam.com. That's TERRY.HURLEY. And I can look up pretty much any account and find out what you get for training coming in and get you an answer. So
yeah, so
either, contact Kevin or myself or your account manager.
Absolutely, and we have a dedicated trainer set up just to train you guys. So, definitely let us know. And I mean, when you guys call in tech support, we can help you as much as we can. But what we're going to try to do is, get your question answered as soon as possible to get you back running on the machine. Now, when you guys take a training course, we are going to go through that with a fine-tooth comb, telling you what each individual button does, what it actually does for your part. And it's a really great time to get a really one-on-one with, maybe you're having troubles with machining a certain part. You guys can set up a training session and kind of go through that part step by step on programming it and what you guys want to see and what every setting shows. So please make part available. Yep, definitely, Carlos. I'll get those parts up there. James, when I'm 3D milling a large mold, then I get to an area on it where the vertical wall only has about a 1 degree draft. It sometimes won't do a finish on the whole area. Like I said before, James, I think what we need to do is just get into a go-to meeting on your particular part. There is a lot of options in the 3D milling to accommodate for those more vertical walls. And what I would do for those more vertical walls is I wouldn't set your step down. What I would do is on your more vertical walls, definitely do a scallop height, because your step down on a more vertical wall is going to be pretty substantial. You're not going to get a nice surface finish. So what you want to do is switch it over. Instead of doing constant step down, do a constant scallop height, where it's, maybe we want a mirror finish on there of 1 thou on there. You're going to get a beautiful finish on that vertical wall. So James, you sent me that part 2 months ago. Looks like I got to go through and James, was that one for HSM that you emailed me? Because I think we're actually going to be going through that part for HSM. No? Okay. Oh, my apologies, James. I was actually planning on using that part for my HSM class, thinking because it was HSM, but definitely I'll get in. Let me know when you're available tomorrow, and we'll get on the call and undo that part with you. Let's see, 5-axis coming in the next month or so. Dwayne, I love it. Get that 5-axis going. Okay. Oh, man, this is still calculating. Trying to think anything else I can tell you guys. Unfortunately, I broke my path by changing some of the parameters up here, so it's taking a little bit of time to calculate. But you know what? We might, no, it's going to still take a little bit of time to calculate. I was going to say I can kill it and start fresh, but I guess that kind of wraps up, guys. I was kind of hoping to show you the, there it went. Okay, so what we're doing here is we're basically coming back with a tool, and what I told it to do is just to cut the rest material. I was thinking this was doing a full finish here, but what I did is I told it to come in with a smaller tool and just cut just the rest material that was missing, that got left by a larger tool. Maybe the bowl nose couldn't fit in there. So you'll see it kind of just comes up in certain areas. Let me get rid of this here, and just kind of cleans up all this stuff that it got missed out on before. Let me uncheck this path here because we're not touching that one anymore. So getting in these tight, small areas, just getting those corners notched out. Now, with the pencil milling, it's kind of the same thing here. If we go to technology, switch over to pencil milling, you kind of see, as I'm going through these, you'll see that my picture updates. So basically, maybe I just want to limit to a certain amount of passes. So if I come right here, I'm telling it to do, I want to do 6 number of passes doing a step over of 10 thou. By tangency angle of my cutter right here is set to 20 degrees. So if I want to set that so it covers more of an area, I can set this to 10 degrees and it's actually going to cut more of the part here. So kind lots of different options in here. We can do direction, you can do upward, downward. Standard is just going to be a default starting from, wherever it thinks is the best toolpath to start from and go from there. But you'll see we're just working on just the radii that got left over here. So, so some of the smaller areas, it's kind of cleaning up, just doing those pencil milling passes. And like I said, just doing 6 passes per one. So if I zoom in on a specific path right here, you'll see 1, 2, 3, 4, 5, 6, 7, 8. I got 9. Oh, some of those paths are actually carrying down here. So I should have 6 lines going all the way across here. And like I said, that's all set up right here by number of passes that I wanted to take. So if I just wanted to do one single pass, maybe my ball end mill was right to size and I just want to kind of buzz along here and kind of go up and around, definitely put that to 1. Your step over won't matter at that point because we're taking it all in one cut versus splitting it up into 6 different times. So with that being said, we're kind of running out of time here. I try to buzz through as much information for you guys as possible, but if there is something that I did forget, definitely guys let me know. My email, phone is always open for you guys, so definitely I want you guys to take advantage of that. I want you guys to experience the absolute best tech support you guys have ever had in all of you guys' machine experience. So definitely let us know if there's something that you guys need help with, something that you guys want to see. Shoot those over to me in an email, and maybe I can't do a whole class on it, but what we'll do is I'll just make a quick little blurb video like we did right here of just doing certain things, doing a certain fixture, and it's only going to take you 1 minute 40 seconds to watch versus watching a whole hour long of me blabbling on. So, but with that being said, we got the Tell a Friend program for those of you guys who are new. You guys just tell us a name and phone number of a buddy that has a machine or that is interested. We'll give you $100 Visa gift card, and if they buy, you guys get 20% of that. So, but also the class that we've done tonight will be on YouTube here, probably about 1 o'clock in the morning. Definitely come check it out, rewatch it. Any questions, just let me know. Like I said, guys, I want you guys to take advantage of this training as much as possible. So I want to thank you for taking your time out of your night or day or whatever time zone you guys are in here. And, have a wonderful night. Darry, you got anything?
Yeah, I just want to thank the guys for the feedback, for the questions, and the thank yous. I really appreciate it. I agree with you. Kevin does a phenomenal job here, and I think it's really helping SolidCAM as well as our customer base. So great job. Thanks.
Yeah, thanks a ton, guys, for the comment. It's definitely uplifting. So, but have yourself a wonderful night, guys, and hopefully see you guys in next week's class, and we'll be covering HSS, like I said, and then we're going to kind of be reversing roles a little bit and going through each operation with the fine-tooth comb, telling you what everything does in there, start to finish. So look forward to those classes, and hopefully see you guys in there in the future. Have a great night, guys. Bye-bye.
Great job, Kevin. Thanks again.
Yep, bye-bye.